Now let's recall. We have discussed molecular mass, concept of mole, Avogadro's number and valency. Molecular mass. The molecular mass of a substance is the sum of atomic masses of all the atoms in a single molecule of that substance. Deduce the molecular masses of these compounds whose atomic masses are given here. We can see hydrogen 1, oxygen 16, nitrogen 14, carbon 12, potassium 39, sulfur 32, calcium 40, sodium 23, chlorine 35.5, magnesium 24 and aluminium 27. So using these atomic masses we have to deduce the molecular masses. A molecular formula given NaCl, MgCl2, KNO3, H2O2, LCl3, CaOH twice, MgO, H2SO4, HNO3, NaOH. Here we will do till calcium hydroxide. Magnesium oxide, sulfuric acid, nitric acid and sodium hydroxide you do as homework. First we will discuss how to deduce the molecular mass. First, how to deduce the molecular mass of NaCl. Molecule NaCl, sodium chloride. Constituent elements. First step is we have to find out the constituent elements. So, sodium and chlorine. These are the constituent elements in NaCl. Atomic mass. Sodium 23. Chlorine 35.5. Already given. Atomic masses are given. Now, number of atoms in the molecule. So, we have to find the number of atoms in the molecule. Sodium 1. Chlorine 1. NaCl. So, Na1Cl1. Atomic mass into number of atoms. Sodium 23 into 1, 23. Mass of the constituent. Chlorine 35.5 into 1, that is equal to 35.5. That is the mass of the constituent element. So, 23 plus 35.5 is equal to 58.5. Now, we will take another example. Reduce the molecular mass of magnesium chloride. First step, constituent elements. Magnesium and chlorine. There any other element? No, only magnesium and chlorine. MgCl2. So, atomic mass, magnesium 24. Number of atoms in the molecule. How many atoms are there here? Only one, MgCl2. So, Mg only 1. Atomic mass into number of atoms. 24 into 1, that is equal to 24. Mass of the constituents, 24. Chlorine, atomic mass 35.5. Number of atoms in the molecule. How many atoms are there here? 2. How? MgCl2. So, 2 atoms are there. Atomic mass into number of atoms. 35.5 into 2. 71. Now, we will add 24 plus 71. So, we will get the molecular mass 95. Mass of the constituents. Molecule KNO3. Constituent elements potassium, nitrogen, oxygen. Potassium. Atomic mass 39. Number of atoms in the molecule. How many atoms are there here? KNO3. So, K1, N1, 3 atoms of oxygen. So, potassium, 1 atom of potassium. So, atomic mass into number of atoms, 39 into 1, 39. Mass of the constituent. Nitrogen, 14 is atomic mass. And what about the number of atoms? 1, 14 into 1, 14. Now, oxygen. Atomic mass is 16. How many atoms are there here? 3. KNO3. So, 3 atoms are there. So, 16 into 3, 40. Now, we will add 39 plus 14 plus 48. So, molecular mass is equal to 101. Now, another example, hydrogen peroxide, H2O2. First, identify the constituent elements, hydrogen and oxygen. Atomic mass, hydrogen 1. Number of atoms. How many atoms are there here? 2. H2O2. So, 2 atoms of hydrogen and 2 atoms of oxygen. So, hydrogen, atomic mass into number of atoms, 1 into 2 is equal to 2. Mass of the constituent. I am talking about oxygen. Atomic mass 16. Number of atoms, again 2. H2O2. Atomic mass into number of atoms, 16 into 2 is equal to 32. Now, we will add 2 plus 32. So, 34. That is the molecular mass. Another example, aluminium chloride, AlCl3. Constituent elements, aluminium and chlorine. How many atoms are there here? Aluminium atoms are there here? Only 1. And what about chlorine? 3. AlCl3. So, only 1 atom of aluminum and 3 atoms of chlorine. So, So first aluminum, atomic mass 27, number of atoms 1. So atomic mass into number of atoms 27 into 1, 27. Chlorine 35.5, atomic mass, number of atoms 3. Again I am repeating AlCl3. Now atomic mass into number of atoms 35.5 into 3, that is equal to 106.5. We are adding now, we will get 133.5 molecule. How to deduce the molecular mass of calcium hydroxide? In this case, there are three constituent elements: calcium, hydrogen and oxygen. So calcium, CaOH twice, atomic mass 40. Number of atoms, how many atoms are written here? Only one. CaOH twice. OH twice is together. OH, outside the bracket we can see number 2 written. So that 2 is applicable for both oxygen and hydrogen. So calcium only 1, OH inside the bracket and 2 is written outside. So calcium atomic mass 40, number of atoms 1. Atomic mass into number of atoms 40 into 1, that is equal to 40 mass, the constituent element. Hydrogen atomic mass 1, number of atoms 2. So 1 into 2, 2. Oxygen atomic mass 16, number of atoms 2. So both hydrogen and oxygen there are 2 atoms. So 16 into 2, 32. So we will add 40 plus 2 plus 32. That is equal to molecular masses 74 here. Now the rest you do as homework. Now we will revise mole. A mole is that quantity of substance whose mass in grams is equal in magnitude to the molecular mass of that substance in daltons. So it's very simple. Molecular mass of oxygen is 32U. Therefore, 32 gram oxygen is 1 mole of oxygen. Now another, molecular mass of water is 18U. Therefore, 18 gram of water make 1 mole of water. There is a chart given here, page number 54. So here we can see few blanks. So we will fill those blanks. So this is the complete chart. So here we can see here few elements. So lithium, atomic number. What is the atomic number of lithium? 3. So you have to write 3 over there. Electronic configuration 2, 1. So valence electrons. Valence electrons means number of electrons in the outermost shell. So here we can see how many electrons? Only 1. So valency. What about the valency then? So in order to attain stability, lithium, it will give away that electron, 1 electron. So how many electrons are given away by lithium? Only 1. So valency is 1. So what is the definition of valency? The number of electrons that an atom of an element gives away or takes up. So in this case, lithium atom is giving away. It can be either giving away or taking up. So valency is 1. I'll take one more example, beryllium. 4. 4 is the atomic number. So electronic configuration 2, 2. So 2 plus 2, 4. So what about the valence electrons? Outermost shell 2. 2, 2. That's second 2. Okay. So valence electrons 2. So valency 2. Again beryllium gives away 2 electrons in order to attain stability. So we can see here beryllium. Now again boron, the same situation. Atomic number 5, electronic configuration 2, 3. So you can identify the valence electrons and write the valency. Now we can see, I am taking another example, nitrogen. 7. 7 is the atomic number. Here what is electronic configuration? 2, 5. So 2 plus 5, 7. Now here we can, what are the valence electrons? 5. 2, 5. So 5 valence electrons are there. So in this case, nitrogen atom will take 3 electrons in order to attain stability. So 5 plus 3 electrons it will take. So octet will be complete. So what about the valency then? 3. How many electrons are taken up by nitrogen here? 3 electrons. So valency is 3. In the case of lithium, we saw 1 electron is given away by lithium. So valency is 1. Here in the case of nitrogen, we can see 3 electrons are taken up by nitrogen. So what about the valency here? 3 electrons. So again, valency means the number of electrons that an atom of an element gives away. Example, lithium, or takes up while forming an ionic bond. Is that clear? So likewise, all the other elements, we can see the atomic number, electronic configuration, valence electrons and valency. Thank you.